Good morning, y'all. Back to my session. This is the second day session. I welcome you all. In this session, I would like to discuss some ideas about multivariate data analysis. How you can do the data analysis using SPSS using one tool, the regression analysis, or you call multivariate regression. In this session, my focus is on, just I would like to give a review of simple linear regression. Then I go for multiple regression. Then I will explain what is stepwise multiple regression if you compare general multiple regression. Then I will take one sample data file, how to analyze the multiple or multivariate regression using SPSS. Yeah, this is the review about the linear regression. As you know about the correlation tool, of course the correlation analysis will give you an idea about how the relationship or an apparent connection exists between two or more quantitative or qualitative variables. So usually the correlation will give you the intensity of linear relationship between two or more variables. Okay, but the correlation do not give any mathematical model equation to predict the value of one variable you call response variable by using another variable you call an independent variable. Therefore, here linear regression will give you the trend value or a good average value for the response variable or you call dependent variable. Fine. Therefore, the linear regression is a way of analyzing the trend, of course, future tendency of the data that we talk about in the context of correlation, which gives only the intensity of linear relationship. But here the linear regression is different. It gives us a model equation how to find the trend of the data for a response or dependent variable using another independent variable. I will explain what is dependent, what is independent variable here. Yeah, the regression provides a mathematical model, of course, a straight line equation of the form like y is equal to a plus bx. Of course, everyone have an idea about a simple straight line equation of the form y is equal to mx plus c. Yeah, likewise here I have taken a straight line equation. This is just you call linear regression. Fine. So here our interest is to find the value of dependent variable y, that is the trend value of dependent variable y. How you can predict the trend value of variable y by using this right hand side equation. The right hand side equation is nothing but a plus bx, that is just a simple straight line equation, right? Now from this you can easily understand this is a function of y is equal to some f of x, right? Okay, forget about it. So now here for different values of x and its coefficient b, there could be some effect on y. Okay, actually what is y? Y is a dependent variable and what is x? X is an independent variable. Fine. What is this b? B, which is a constant coefficient of your variable x. Okay, what is this b? This b is nothing but how much quantity of number of units of your x, variable x, influence on variable y. What I mean to say from this equation, how so far there is an influence of your x on y that will be obtained by this quantity b. Okay, in general you should remember that this b is nothing but the coefficient of x, which gives us an idea about how much influence of x with respect to b on y, it will give. Fine, and a is a constant. Okay, so here if you can take value of x is 0, then this term is 0, then your y is a. Y is equal to a. That is the initial value for y. Fine. This is very simple linear regression. You can have only two variables. This involves only two variables. Fine. Let us suppose that the model equation for a simple linear regression equation to predict your y. Okay, now so how you can predict your y? I am taking one simple example about the exam score and how many number of hours a particular student is spent in order to revise his exam. Fine. So that's why exams usually exam score is depends on now here hours spent for revision. Fine. Yeah. Therefore, my y is exam score. It is a dependent variable. My x is an independent variable. Fine. What is y? Y is the exam score, and your x is number of hours spent for revision, or number of hours work, number of hours work for his revision exam. Fine. So in this way, it is easy to obtain the exam score by using the number of hours spent for the revision. So here beta, this is the coefficient, right? Now, how much quantity of beta with the number of times of x, there is the influence on y that we can find. I hope you understood now. This alpha and beta we need to know. Okay, so this is a simple model equation to find the to predict the exam score with respect to number of hours worked hard or number of hours spent for revision. Right here, I would like to take one SPSS data file, that exam revision data SAV, or some other file is also there regarding the IQ of a child. Okay, any one of the data file we can take and I will explain. Fine. Yes, this is about multiple regression. Okay, so what is the multiple regression? How so far the multiple regression is different from your linear regression? Usually a simple linear regression involves only two variables. Okay, one is y and another is x. Y is a response or dependent variable and the x is independent variable. But whereas in case of multiple regression, this involves a number of independent variables and dependent variable is uniquely defined, right? Yeah, so that's why here just for multiple regression I would like to include more than one independent variable. Okay, and for each new independent variable we need to add a new term. What is that new term? Here new term is nothing but a coefficient, right? Here what could be the model equation? Multiple regression model equation is given by like this. My y is a dependent variable or response variable, right? This is depends upon what? X1, x2, x3 and their coefficients, right? Now y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on plus beta k xk. How many number of independent variables you can have? K number of independent variables you can have. Please try to understand. Just I have extended my linear regression with a single independent variable to now multiple independent variables. That's why we need to go we need to define a multivariate regression equation, right? So that here now your dependent variable is y and the right hand side variables x1, x2, x3 and so on xk are independent variables. Here please try to understand beta 1, beta 2 and so on beta k are the coefficients of respective independent variables x1, x2 and so on xk, right? So here the influence of your x1 with respect to its coefficient on y is that beta 1 times x1, right? So that is the influence on y. Similarly for beta 2 times x2 on y and so on. Beta k times xk on y, right? If you were x1, x2, xk are 0 or beta 1, beta 2 and so on beta k are 0, then your y is equal to beta naught is a constant. This is very simple multiple or multivariate regression equation, right? If you can have some population data, some class data, then you can easily define the regression line equations, right? Yeah, same, nothing to worry. Just you should remember those equation or this is equation, this equation, right? The population equation is given by this is the this is the multiple regression equation for one dependent variable and k independent variables, right? Yeah, this is this is the equation I'm taking for entire whole population. Fine. Yeah, the whole population, we have one dependent variable. Dependent variable is y is equal to, now this is depends on variance on number of k independent variables, right, with respect to their coefficients quantities. In that way, y is equal to beta naught plus beta 1 x1, beta 2 x2, and so on plus beta k xk. Right? Here, this is a representation of a population equation for multivariate regression analysis. Right? Entire thing is same. I am taking this multiple linear regression equation for population. That's all. Right? Yeah. Here the betas are the coefficients for each and every independent variable for our true population. Okay, so how many number of independent variables you can have? X1, x2, x3, and so on. Xk independent variables you can have. Fine. Yeah. Now the sample equation is different from the population. From the whole population, you can pick only some part, some finite subset. Right? Like from whole college, you can pick your class. Now your class is a sample. For that sample class, our interest is to find the trend or tendency of like marks score, okay, or academic performance. Likewise, you can take as a dependent variable, okay, the expected value or the best trend value for your, let it be exam score or let it be academic performance. We do not know. That's why you can say some y cap j or simply y. Okay, no. So that is equal to, after uh, analyzing your data, you will get the sample regression equation like this: beta naught plus b naught plus b1 x1 plus b2 x2 and so on bk xk. This is the way to get a sample regression equation. How you will be getting this sample regression equation for one dependent variable or response variable yj or y, and with the k independent variables I will explain. Right? Yeah. So now the multiple regression process. Actually, what is this? The concept. Okay, the process involves using data from a sample to obtain an overall expression of the relationship between what? One dependent variable and multiple or k independent variable. Let's say x. Right? Yeah, this is done in such a manner that the impact of the relationship of the x you can easily collect it, and individually on the value of y. It can be estimated. This means what? Just you collect all the independent variable, their values with their coefficients, which are depends on which are independent, and your y, that is response variable, depends on all these collective independent variables. Fine. Yeah. Now this is about the concept. Just now I have told a multiple regression is a straightforward extension of the simple linear regression procedures, whereas in bivariate situation you can have the simple linear regression. In multivariate situation like x1, x2, x3 and so on, we go for the multivariable regression analysis, right? So in linear regression analysis, just you can have one dependent variable, one independent variable, but whereas in multivariate regression analysis, you can have one dependent variable and number of independent variables, right? I will explain through one example. See, just I am taking here the Korea example. In Korea example, just this is nothing but a sample data file I have taken from a clinic, right? Yeah. Here, what is my dependent variable? My dependent variable is y. Please try to understand. My dependent variable is y. What is y? Y is body mass index, BMI. What is body mass index? Body mass index is a measure of body fat. Fine. For the sake of your understanding, I am taking a simple example. Then I will take uh, uh, the example which is related to your ELT. Fine. Yes. Now, yeah, the body mass index or body fat, that is depends on what? Different variables. As an example, here I have given x1, maybe age in years, and x2. My x2 is nothing but a double F num. What is this double F num? This is nothing but a measure of fast food usage. For example, let us say number of times eating fast food in a week. That is your X2. Fine. Then X3. X3 is exercise. Right? You can have here an exercise intensity score. Fine. Then what is X4? X4 is another variable. Just here I have taken alcohol quantity per day. Okay. Now the question is body mass index or body fat influenced by which variable? Either X1 or X2 or X3, X4. Right? How you can find? Yeah. The multivariate regression analysis, by analyzing the data with the help of SPSS, it will give you an idea. Body mass index or body fat, whether it is depends on age, depends on fast food usage in a week, depends on exercise intensity score, or depends on taking alcohol. Fine? Yeah. What kind of regression equation you will get ultimately? Right? Yeah. What is Y we do not know. That is, I would like to say Y cap. This is nothing but a body mass index. Let us say we will find by using some the regression analysis procedure using SPSS. Okay, now yes, beta B naught. This is some constant value. Then B1, how much quantity of uh, X1 which is influencing on YJ. Then B2. Okay, so Yj is influenced by how much quantity of this. So likewise, you can easily estimate. Okay, now this is one example. This is another example. I am taking one sample data which is having one dependent variable. The dependent variable or response variable is nothing but exam score. Or you can take academic performance of a student from your class, right? Yeah, sample class. Now, what is X1? X1 is the number of hours spent for revision. What is X2? X2 is nothing but anxiety. Okay, anxiety is nothing but a strong desire. Okay, like a strong desire. Sometimes, of course, weariness also. Right, X3. What is X3? Yeah, X3 is another variable that gives us an idea about entry points, A-level entry points. This is another variable. Right. Now here the question is whether exam score is influenced by X1, variable X1, variable X2, variable X3. That is hours spent on revision, maybe due to the anxiety, maybe due to A-level entry points, right? So these three are different variables, right? Here I have with me one data set which is exam revision.sav SPSS data file. Okay, finally, you have one dependent variable, three independent variable. You can fit a multivariate regression analysis, or you can find a multivariate regression equation. That is Yj is equal to B0 plus B1 x1 B2 x2 plus B3 x3 and so on. Right? Yeah. Now the regression procedure is the same discussion. I would like to mimic with my SPSS data file. Now I am going back to my SPSS. I am going back to my SPSS data file. I am going back to my SPSS data file. Okay, fine. Yeah, what is your SPSS data file? I'm going back. Yes, this is yeah. Uh, sorry. Yeah. Uh, I'm taking another data file. Okay, that is revision score. Okay, no? Yes. Just a second, please. Yeah. Now, yes, already just now I have my data with on my SPSS. That's why I'm taking. I'm going back to that exam revision. Yes. 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 These are the scores. Okay. Yeah. See variable view. Yes. Yes. Now exam score is one variable. Second one is hours, revision, anxiety, and this is entry point. Okay, now yes, you have an idea how to create the SPSS data file. Here you can have four variables. One is dependent variable and other three are independent variable. These are the scores. Now how you can mimic the data for the data analysis? Our interest is what? Our interest is to find a regression model equation to know this exam scores, which is based on number of hours revision, anxiety level, and entry point. Fine. What I am doing, just you go toolbar, top menu, item analyze, click on that. Okay, just you move down, then you can see the regression. Okay, then linear regression, right? Your first interest is the linear regression. Then what is your dependent variable? Exam score is dependent variable now. Then what are other independent variables? That is hours spent, anxiety, and A-level entry. That's why here, what is dependent variable? Exam score is dependent variable. In this dependent variable box, you enter input or plug in exam score. You can have three independent variables: exam spent, hours spent, anxiety, and A-level entry. Now click on that you input or plug in independent variables box. Fine. Now initially what is the method? Initially the method is enter, right? Then statistics. If you want to know the statistics for this, you can take the descriptives. If you want to know the confidence intervals, you can take confidence intervals with a 95% confidence level. Oh, okay. Already I have explained what is this 95% confidence level. I am continuing. Then plots. If you want to draw the plots for dependent variable and the predictor variable. If you want to draw, you can. I'm taking the dependent variable is y. Okay, of course, you can take the predicted value. What is the predicted value? And it is it's a residual. It will give you the difference between the predicted value and residuals predictor. Okay, or else you at this stage you do not take. Okay, I will explain later. Yeah, leave it. Yeah, then continue. Now see, then options. One more. Yeah, this is no need to worry. Then bootstrapping. This is simulation purpose. No need to take. Fine. Now you can run the show. Okay. Now come and you can say okay. Fine. Fine. Yeah. In input view. In output view. In output window. Now the linear regression analysis complete output is displayed. Right. First one is the model summary. The first table refers gives an idea about the model summary. What is this model summary? In model summary, you can find actually descriptive statistics is also there, right? This is about the descriptive statistics. Sorry, yes, mean HDs, exam score, hours spent, average hours spent, anxiety level, and so on, right? Yeah, these are the correlations, right? These are the correlation. Okay, in between exam score, hours spent, anxiety, A-level entry points. You have an idea of what is the correlation and how you can find the significance, right? Just you can see my exam score and hours spent is 0.86. What could be the significance? Yeah, it is highly significant. There is a connection between the exam score and hours spent for revision. Hope you understood, right? Yeah, forget about it. Now come to here. What are the variable? How many number of variables you have entered? Three. What are those? Yeah, anxiety, hours spent, and A-level entry, right? It will give you actually. Then come to model summary. Now model summary. What is this model summary? Model summary, the first column will give you the coefficient of correlation. The coefficient of correlation for these three predictors with your variable exam score is 0.933. This is very high. Fine. Yeah. There exists a relationship between them. Now R square. R square is nothing but a coefficient of determination. Okay. This is the square of your coefficient of correlation. It is now 0.871. This covers this 0.871 is nothing but 87.1. This 87.1. This gives this much variation is analyzed with these three predictors on your dependent variable y. What is the dependent variable exam score? What is the meaning of that now? The exam score is explained by the three predictors with a 0.87 or 87.1 percentage of variation. In that way, you can give an idea. So now this is adjusted R square. Of course, you should concentrate on adjusted R square also. The adjusted R square is now 86.7 percentage. Same. Here your exam score is explained by using the three predictors. The adjusted R square value is 86.7 percentage. It is high, of course. It will give you an idea. There is a significant. There is a high variation of variance is explained by using these three predictors for exam score. This is a good result actually. Fine. So if you'll be getting more R square or more adjusted R square, it will give you a clear cut idea, or of course your model is best. On the other hand, if you can have an idea about the analysis of variance and you can apply the ANOVA, okay. So here the analysis of variance will give you for this regression analysis whether your regression tool or linear regression is the best fit or not. Fine. Yeah. So that's why here the model is having in this model it is having now the source is regression and residuals of regression. Fine. So sum of squares, degree of freedoms, mean squares it will give you. Actually you are analyzing the variation in between and within the data using the ANOVA. Now ANOVA has a tool like t-test. Here if you can have f-test. When your f-test is having the large value, it will give you significant. Now what is the significant value here? It is 0.000. This is less than 0.05. This means what? Your p-value is less than 0.05. P-value is less than 0.05 in this, and this is highly significant. Fine. Yes. This at this stage, at this moment, what can you say? The regression model is the best fit for the data. Now you can move. Now this is the line. This is the last and final stage. Here the coefficients of variables means independent variables, right? Here, what is this? Actually, it will give you the complete idea about your dependent and independent variable, their coefficients, and how much influence is there by all independent variables on by, okay, whether the values are significant or not. That much idea you will get from this table. Clear? Try to understand. Hope it is clear to you. Yes, forget about constant comes to hours spending for revision. Hours spending for the revision, the coefficient B value is 0.575. This means what? So there is a effect of hours spent on revisioning with your x1 variable, that is hours spent on revision on exam score, that is 0.575. Whether this is significant or not, just you come your t-test value. This is based on t-test actually. T-test will give you an idea to test the significance of your particular regression coefficient or coefficient of excess. Fine. Now just you can see whether it is significant or not. P value is significant, right? P is less than 0.05 now, so that's why it is highly significant. Okay, now so these are the 95% confidence intervals of your data. See, your B value is 0.575 now. See, you must have that B value in between 0.441 and 0.70170. Okay. Now what about anxiety? Anxiety score is 0.101. Right? Whether this is not significant or not. T-test value is 4 point. Again, P value is less than significant. This is your X2. Then A level entry point, that is 1.99y. So this is also significant. Now it is easy to write your regression equation. How can you write the regression equation? See, I would like to write the regression equation on your Word document. Just I am taking one Word document. Just I would like to put this output on my Word document. Okay, now. So just I am taking Word document. Fine. Now just you can paste that Word document. Okay. Yeah. Just a second. Okay. Now what is your regression equation? Your regression equation is, yeah, I'm increasing font size. Just wait. I'm increasing font size. Yeah. I increase my font size, please. Now this y is equal to what? Now y is equal to, you know, that b naught, right? B naught plus b1. b1 into what? x1. b1 into x1 plus what is another variable? b2 into x2. What is another variable? b3 into x3. Fine, this is one. Now, yeah, you can see what is y exam score, right? What is your y exam score? Yeah, your exam score is equal to y. Yes, see. Now y is equal to, what is the constant value? Constant value is minus 13 point, minus constant b naught value is minus 13.013. Okay, 13.013 plus, what is b1? b1 is nothing but a coefficient or quantity of your x1, how much influence on y. So that's why now you can take that is 0.575, right? This multiplied by what? x1. Okay, yes. Similarly now, plus what is another variable? Another variable is anxiety. What is its coefficient? Its coefficient is some value. What is it? 0.101. What is this now? x2 plus, what is another variable? Another variable, entry points. What is entry point value? 1.995. What is the variable that is entry point? Just we have treated as x3. What is happening? Just you can see this is your model regression equation. If you can substitute your x1, x2, x3 scores in this, ultimately what is your exam score? Fine, you will get easily what is your exam score. Clear? So this is very useful, how to predict the value of your dependent or response variable y, such as exam score. Clear? I hope you understood. Yeah, this is about linear regression. Just what is the stepwise regression actually? Just I would like to extend the same for stepwise regression. Okay? Yeah, just I'm going back now. Just you can see. Yeah, stepwise regression. Stepwise regression is nothing but you can have three variables with one dependent variable. It will do one by one. Okay, so that's all. Here, just I'm going back. Okay, I'm going back to linear regression. Already I have done enter now. Just now, I'm going to save. Then you continue. Then enter, in enter place you give stepwise. Even you go by the backward process or forward process also. Okay, I'm taking here stepwise regression. What I'm doing, I'm going and do analysis. Just I'm clicking. Now just you can see how it is happening. Yeah, exam score, hours, this is same. Okay, here you see the correlation already given. Yes, now you can see what are the variables entered in model 1, first variable, in model 2, second variable, step 1, step 2, step 3, like that. Fine? Yeah. Now model summary is this. This is a model summary. The same here, the regression, the ANOVA table for individual variables, it will give you. All the variables are significant. For each variable, the model is the best fit. That is the way. Now, here you can see the coefficient, just now what I have explained. Fine? Yeah, the same. What is constant value here? Here, the constant value is this much. What is the variable x1? Variable x is this much. Okay, the quantity for variable x1 is the coefficient b is 3.17. Whether it is significant or not, just you can check. It is significant. Fine. I'm not. Yeah. Then come to model 2. In second step. In second step, now you can have two variables. In third, you can have three variables. Okay, this is the way. This is the way you will get the significances of that particular variables. Now you can write again the regression equation in a Word document by pasting this table. Or directly you can take the values of each and every variable and you can put on your Word document in research article or and thesis, and you can take the coefficients only, and you can take the write the model equation, and you can put the all the values are significant by giving p-value less than 0.05. Already it is showing, it is displaying here. Fine. Yeah. Now if you can exclude some other variable by stepwise, you see the hours spent excluded variable for anxiety. Hours spent anxiety, the last one is this. Okay, in that way anxiety here not showing the significant, right? This is the way to do the do the stepwise regression analysis. Now again you can write the model equation by taking what this two. This is not significant, this is significant. Okay, hours spent is significant here, and here anxiety is significant. Okay, following we can write the model equation now, right? So this is an idea about the stepwise regression. Hope you understood. The same you can proceed with the forward, and same you can proceed with the here. Just you can have use, you can see that this is a backward, then forward. Of course you can use the remove option also, right? If you can use the remove, it removes one variable one by one, and it will give you which variable is highly significant. Likewise you can do the analysis. This is the beauty of multivariate regression analysis. How can you do with the SPSS package, SPSS software? Okay, yeah. Just I'm going back to my slide. Yes. Now, yes, you can take this. It takes 10 minutes. Then get back to you. I'll get back to you with another multivariate analysis tool. Principal component analysis. Of course, support is factor analysis. Thank you all for listening patiently. Thank you very much. Catch you back within 5 minutes, within 10 minutes. Thank you.